Cancer going great. Okay. I'm going to do this and then all right. So um, we aren't going to be adding any additional shapes or anything like that for now. So I'm going to minimize this as much as reasonably possible, try and get our full image width here. Yeah, definitely an interesting week. All right. So pseudocode helps if it's spelled correctly. Pseudocode. Couple things that we need to know about transferring this. We went to kind of start setting some of this up in code, and very quickly it gets a lot more tangled than we think. So there's a couple principles that we want to kind of familiarize you guys with. And the first is something like comment with title. Comment has two M's. Little keyboard dyslexic today for reasons I can't explain. It's a bad thing to be when you're trying to do programming. So something like make me a sandwich. So we have a comment with a title. What pseudocode is going to do is be code-like, but we're not trying to write it in terms of exactly what the code is going to be doing. And then we're going to look at how to transfer this pseudocode into code. And we'll kind of go back and forth between the pseudocode and the code and see if the pseudocode was actually detailed enough for us to do what we're trying to do or not. So the program starts. We're going to do something like initialize the variables. Namely, we're going to have initialize the variables spread type. We're going to have main ingredient. We're going to have second ingredient, and so on. These can also be when we're doing pseudocode, instead of making lots and lots and lots of lines, sometimes it can be best in terms of formatting to do bullets or something like this, just to make this very easily readable, like a high-level roadmap. Second ingredient, third and fourth. And then third and fourth ingredient. All right. So the initialize the variables is the way that we can then use them later. This is a good habit of putting at the top of our pseudocode and thinking through, I know I'm going to need, as a minimum, these things to be able to do the data manipulation that I'm going to do later. You can always come back and address those, but these kinds of steps are not really included in our flowchart, because the flowchart is very much high level. So this is like maybe the flowchart is like your 30,000 foot picture. So you see kind of the whole big picture. and get some idea as to some of the directions and steps that you'll need. Then the pseudocode brings you down to something like 10,000 feet, where you're still flying a little ways up, but you can see individual cars and sort of maybe people. At least you can see things moving around on the ground and tell that there's buildings and tell cars apart from each other, stuff like that. All right. So the next step after we've initialized the variables is we need to print um, the we don't need to go to the level of pseudocode, like saying, for instance, uh, setup code or something like that. We don't quite have to go to that level, um, but we want to initialize the variables. Then the next step is going to be the actual main body of the code, and we're going to say print text, um, and then what we want to print, something like do you prefer gluten-free? Um, so we're going to do something like print this text. This is enough detail level for pseudocode for us to be able to get by. Then we need to take user input, um, and this is where we, in the code, we have to think about whether or not this is precise enough, and even in the pseudocode. So we're going to kind of we're going to think this through a little bit. We're going to take the user input, and ideally, this is where something that we ran into when we started actually working on the code. We really need something like a 1 or 0. When we get a little bit more advanced and we're not as afraid to deal with strings, which can include misspellings and all kinds of other stuff from user inputs, strings become a lot harder. 1 or 0, pretty straightforward. Most people can get a 1 or 0 right. We needed take a user input, 1 or a 0. We need to store user input to variable, to appropriate variable. So for this one, it's going to be spread type. So we need to further clarify. We realize when we write this line in pseudocode, if we just take user input in, we could store a string or something like that, but then we have to evaluate the string later and build lots and lots of additional lines of comparison code. This simple way to handle this is enter 1 for yes, 0 or 0 for no. Um, so enter 1 for yes, and this could be included in parentheses or something as a guideline. And then take the user input 1 or 0, store input to appropriate variable. Then we move on to the next step. So um, we've covered this portion already of the algorithm. So there's a lot faster to do in the pseudocode step than the actual writing of the code, right? So now we're going to do, what main ingredient do you prefer? So print text. and then give them a list. You're going to have to list out 1 through 5, but you can copy this. So same kind of idea. The easiest way here is to enter 1 for, if we start from left to right, 1 would be cheese, 2 for salami, 3 for turkey, 4 for chicken salad.
Excuse me.
Yeah.
Should we use like the numbers like in ours? Should we use like the numbers that the assignment give us, or does that really matter?
You can definitely. In this case, we're looking at it from a user experience perspective, but that's actually one of the roadblocks that I had left ahead of us. So that when we get there, we have to go, oh, actually, we're going to have to reassign a variable. So we're going to have a discussion of that point at some point anyway, so we can do that now. What percentage of you guys would use the actual numbers from the assignment? That's the real question. So let's do 1 for use the numbers for the assignment because it's easier, 2 for let's not use it, and 3 for, let me stop sharing for just a second and drop the infinity mirror, and 3 for turnip. There's always somebody voting turnip. Because 2 is keeping things simple in the code. If we leave it like this is, it keeps it fairly simple and straightforward. It's not that much harder to use the code from the assignment, but yeah, we can definitely do that for the sake of simplicity. So, all right, I'm going to grab those numbers as soon as I can get back over there. Because that does reduce a reassignment step for variables later. So that's perfectly reasonable. I've had to do a reboot, so I don't have that. I don't have that available. So 1 would actually be turkey. 2 would be cheese. So I think I have those reversed here. So I'll correct these real quick and then go back into the sharing so that we avoid the infinity mirror fun. So 1 is turkey, 2 for cheese, 3 for chicken salad, and 4 for, because otherwise you leave yourself vulnerable to making mistakes, and lots of them. Lots and lots of them. 4 for salami, 5 for, so 1 for turkey, 2 for cheese, 3 for chicken salad. All right. Or 4 for salami, and that's our selection. So we can repeat that and copy and paste the logic blocks when we go to do the code. So now I can jump back over to the other window. Go back to this. All right. So we're still referencing the information here. but we've got our selection fixed here as far as printing the text. So what main ingredient do you prefer? So we're going to be able to copy and paste that a couple of times, but we're going to go ahead and fill in some of the other pieces from our logic here. So we select, we print that out. We take user input 1 to 4, and then store input to appropriate variable. So this would be main ingredient. So then this text we can do, again, depending on how you've set up your specific algorithm. It may be that you have something like a loop that starts here before you print. You might be doing this in a loop, but then you have to understand how to break loops and do things like that. So we can do this to kind of keep ourselves in line. So first one, second one, paste. This is the third one. And then the fourth one. Yeah. Nope. Okay. All right. So take advantage of the formatting. So we have 1, 2, 3, 4 iterations, and we update a couple of these. So this is, you're going to update each of these and use the word second. So second ingredient. This is going to be third. So third ingredient is going to be here. Third ingredient. And then fourth ingredient. Fourth ingredient. There we go. So fourth ingredient, store that to the appropriate variable. Okay. Then, as the very, very last step, we're going to take those numbers, and here, for correcting gluten-free, we can say 44 for yes and 99 for no. It's a little bit of an unusual input, but we'll change those as well, so that then you store those to bread type. So then we can print text you ordered, and then print text next line, bread type, let's see, bread type, yeah, bread underscore type. Okay. So we've got bread type
Quick question.
Yeah.
Could we just simplify for the user and have them still put 1 or 0 and then have that translate into like 1 means 44 added to the variable?
Yes. Yes. And in fact, that's often what programs are actually doing in the background. The other thing that we need to add is the option for option 5 of option 5 for none, basically. So we need to include that if we're being complete. So then these are actually all 1 to 5 instead of 1 to 4. So very often, yeah, you can store it as simplified matters. So you could still use 1 or 0 for yes or no. You could use Y or N. String detection gives them a lot of opportunity to misspell things and create errors. Then you have to do lots more levels and layers of error handling, and you have to build your own library of like ways they can mistype things, which that's when we did the great transition, which was before like probably before all of you were born. The transition from T9 text to texting with a keyboard, a full keyboard on phones. There was a thing that happened on the internet called TEH instead of the, and it's still used occasionally in memes and things, but it comes from the era where people would misspell the using T9, and it got carried over into full word texting. So even if it's 3 characters, don't give the people the opportunity to mess stuff up. And that's why apps are all like buttons and sliders now. Really hard to mess it up. That's why. Also, people are generally just dumber, as evidenced by that whole, Ford Taurus drive-through incident. It's going to be the new standard. So yeah, you can use other variables and store them. That's the cool thing about a program is you could be printing out things one way and then storing them on the back end into variables with all sorts of different names and ideas. So bread type, we're going to print to next line. We're then going to do that same thing, print to next line, main ingredient. Then we're going to print to next line. So we're actually going to copy and start from that one because it'll be a little quicker. Second ingredient. Now, this also doesn't take into account the logic for print to next line. Fourth, this doesn't take into account the logic, and then bread type again. Okay, bread type again. And there could be further additions to this program where you could say, is that correct? Yes or no? If no, then you add to the flowchart. Yes, then end. No, then loop all the way back up to ask the user about gluten-free. So you could do that. There's a number of different ways to implement that in code, but we're going to focus on just the fundamentals. So the pseudocode is really not all that bad, and this is enough detail that you can reference because you're printing text. That's a clear operation. You know what you're doing. You know what kind of functions you're using there. store the user input, take, now you print text output, take user input, store it, print text question, take user input, store it. This is clear because we're not trying to, in this part of it, we're not trying to clarify, but in this, we're actually going to be printing, we're going to need these variables, the turkey, cheese, chicken salad, etc. Actually, for the assignment language, no, they're having you just okay. So they're asking, instead of this step you ordered, it's actually so this is like a backhouse ticket. Please make this sandwich. And so it's going to be the number of ingredients. So we're going to print the, we're actually going to be printing the number from bread, the number stored to bread type. We're going to be printing the number stored to main ingredient, then second ingredient, then third, then fourth, and bread again. All right. So we're actually printing the number, not the text. But we're going to print the number each on the next line. So there's a couple things we have to do that. So this is what we're doing for the pseudocode side. All right. So any questions on this? Let's jump back over here and stop sharing for a second. Any questions on this? Yeah.
So the flow sheet is just sort of in how you want the code to be ordered. And the pseudocode is it's describing what you want the code to do with basic terms that are related to commands that you use in the software.
Correct.
And then the actual designing the algorithm part is the code itself doing what you've described it's supposed to do.
Correct. Yeah, the pseudocode is there to put it into programming like language, because I know I can print text to the screen, but I don't have to write it in the code format. So I can say print this text to the screen, and it'll be for this user, print this thing for that, etc. The idea there is to trying to use this as again, this is like coming down to like 10,000 feet. You're starting to think in terms of, okay, what kind of functions am I going to be calling? What kind of processes am I going to be doing? What moving pieces am I going to need to be able to put this into practice? And that's important. So that's what we're trying to do, is organize our thinking about the code from what the flowchart's supposed to do to what we need to be able to do in order to translate that to code. So that's why that's a very important step. Other questions on this?
What's something you don't want to see for the pseudocode thing? What is a common mistake you see people make with these?
That's a fair question. A common mistake at this level is not being detailed enough, or equally being overly detailed for what the algorithm's trying to do. So an example of not being detailed enough would be you would just say ask user for number input or something, right? It needs to be specific enough that when you go to translate it to code, if you were going to that's really one of the best ways to think about it, is if you were to hand this pseudocode to someone else who is a competent coder, would it be immediately obvious to them what you're trying to do? Yes or no, right? Like if it just says store user input, that could mean so many things. So many things. What user input? Your phone, how many different gestures does it have based on different things, right? You have the accelerometers, you have the cameras, you have all this other stuff. So the phone is, depending on what app you're using, tracking the motion of your hand. It's tracking the focus of where your eyes are on the screen. It's tracking, to some degree, facial expressions and things like that. And even when you like take your phone away and look away in disgust or something, like all of that is all technically user input. But the user input that you're thinking of in the code, the pseudocode that you're writing, probably is direct inputs like typing numbers on the screen, right? So there's levels and layers of user input depending on what kind of device you're programming for. So that's part of what we have to factor into the process. So anyway, that's what I want you guys to focus on, is being specific enough. Like, I'm going to have them enter 1 for turkey, 2 for cheese, 3 for chicken salad, etc. Then we're going to have a line in there that says, hey, we need to take in that user input. So that necessitates something like having started the serial port, having opened the serial port somewhere along the way, right? So this is part of what I want you guys to kind of be thinking through, just because that'll help to make sense of the steps that we're doing, right? So let's take a look and see. All right, any other questions on this? So like one of the ways that I didn't technically show this. So one of the ways that we could do this is we could still have them enter 1 for yes or 0 for no, but we could take the user input and we could say store as 44 or 99 from 1 or 0 respectively. So now we have a note that says, hey, I need to remember internally on the code side of things to store this as 44 or 99, even though the user is going to input 1 or 0, right? So this is how we would address this at the pseudocode level. Then at the code level, there's a couple things that we're going to have to do, but it's not super scary. So from here, when we go to actually translate back from pseudocode to code, the thing that you want to evaluate is a competent programmer, or somebody that you can think of as, like, if you were to hand this to one of your upperclassmen or something, would they be able to take this and turn it into a working algorithm for a project or something, right? Like, these are some of the questions that we got to think about a little bit. if we've achieved that, then great. So here we have a title. We're going to set up variables that we know we're going to be using. We're going to print text for the user. We're going to take any user input. So this is one line of code. This is one line of code to take the user input. The store to the appropriate variable. This could be 15 to 20 lines of code by itself, but it's one process, and it's going to be the same kind of process as this one, and the same as this one, and the same as this one for the third ingredient, and the same as this one for the fourth ingredient. So this is one line in pseudocode, could be 15 to 20 lines in actual code, but it's going to be very similar for each case. So we don't have to like spell out exactly what this is, but we do want to be specific in areas like this where we say, hey, I want to keep the user experience simple by telling them to enter 1 or 0, but I'm going to store that on the back end as 44 or 49 or 99, right? So any questions on this before we go to translate that back to actual code?
So is this basically what we're turning in for the part 3?
So yeah, this is I think technically part 3, and this is why you guys can see that this probably should be part 2, probably, but it's not because reasons. So yeah, this is essentially like the level of detail I'm looking at, because this, if someone were to hand me this, that's enough that I could figure out some of sort of the pieces in the middle there, which simplifies things a bit. All right, now we're going to go to the actual code. So I'm going to fire back up. That was what I didn't get up earlier. Okay. So read capacitive buttons. Let me see. There we go, sandwich selector. All right, so I'm going to set this up to be all right, so we're going to go back to our pseudocode. Okay, so here's where we are. I'm going to go back to sharing this. There we go. Okay. So now what we're going to do is we're going to talk about how we translate over from pseudocode to the actual algorithm. So we start with some kind of a comment in the title, so we remember what it is that we're trying to do. So I've got that here. Since we started on some of this, we're a little bit ahead of where we would be, but for the most part, for something like this, the reason you lay it out in bullets is you can quickly copy and paste this section, drop it in here, just add your INTs and your semicolons or your colons, and you can then get in and as appropriate for all of the different pieces of this. And by spelling out in the pseudocode the text like you want to use it, you can copy and paste that into your print functions. So for this, I can update, but there's a step here. Hey, we need to begin the serial. So here we could argue that the pseudocode would be more complete and more accurate if we said something like this: open the serial port to allow for input and output. This I left open intentionally so that we would have that option to come back to, just because this is one of those details in pseudocode that it's helpful to put this in to remember. So if you had an inexperienced coder like one of your fellow classmates, and you handed him this pseudocode without this reminder for open the serial port, they might not remember that you need to do this. They might just go press forward and do serial prints and serial reads, and they just start getting errors because you didn't remember to say, hey, we'll initialize the variables. We're going to open the serial port to allow for input and output. Then we're going to start printing text. Because without this line in the pseudocode, really technically none of the rest of this stuff is possible, right? So that's another landmine that I left for us to step on. You're welcome. You still have your legs. We're not actually in North Korea, at least not yet. Yeah. I will say somebody with questionable taste in terms of timing had set some of those pager videos to POD's song called Boom. And that was definitely not the most unhilarious item of the week. Just a thing that I happened across. Speaking of timing and, you know, ones and zeros and stuff. Okay, so serial print line. Do you prefer gluten-free? I'm going to change the text here to match what we have. So but you need to include this in quotes, otherwise it won't know that it's a string. So that's a very important piece to this. If you don't have quotes, now all of a sudden all of this, all of the everything afterwards, if you go to do a serial print line, this all changes color. The second I add in the double quotes, this all changes back to orange. This is now comments and everything. So the quotes is very, very important. That's the reason that I do this in pseudocode with quotes. Is it's not, again, completely coding language, but it's subtle reminders. Oh yeah, I haven't coded in this language for a few weeks. I remember I need to do this. So it'll help when you leave yourself some breadcrumbs like that, or somebody else that goes to put the code in. So here in pseudocode, you don't necessarily need to include delays, but you can, right? So you could print and add a delay right before each of the take user inputs. In practice, in code, you absolutely want to do that. But that's not always going to show up in the pseudocode unless there's a very specific sequence of things that you need to happen, or if it's a lot of inputs at the same time or something like that. There are instances where you'll need to note that at the pseudocode level. So we've gotten to here in the pseudocode, and we are almost 20 lines in before we start actually taking the serial in. This step, the check for response if serial.available, it's not strictly necessary, but it will help diagnose things that are going on if you carry that forward. So the concept being if serial dot available, so if the serial port is available and there's data coming through, then read the serial and do this thing. So the following ones, once we've checked to make sure serial is available, rather than running all of everything in a whole while loop, there's a couple different ways to do it. This closing curly brace we don't want to mess with because that's the one that closes the setup. So that's your bread on the sandwich setup, keeping it together. So you don't want to mess with that. Once we've done one condition check with the if serial available, for the level of coding that we're doing right now, it is reasonable to presume that that is working adequately, and that it is reasonable to presume that once we've read in a bread type, we can now move to the next steps. We're going to learn more about error handling and things later. So if the serial port is not available, like for instance, your USB cable, one end or the other is not working correctly, or the USB on the board is having troubles, or the USB port on your laptop or Surface or whatever you're programming from is dirty, or not making good contact, all of those sorts of things would trigger a condition that if the serial is not available, this is the counter implication. So I want to do this in a comment so that it's clear. If serial wasn't responding, the code would skip the above if and start from the next line below. So if serial was not available, then it would skip everything contained by this curly brace sandwich. Everything in the middle there, it's going to skip over. So it's not going to do the serial read. It's not going to do it's not going to do the things. So the next things that we need to do are, again, a serial print line and a delay. I'm going to write these from scratch since I'd have to change basically everything about these up above. I'm going to write them more from scratch by starting here. And I'm going to copy this part of it. And I'm going to say, I'm going to do a tab just because spacing wise, it when you're inside a loop or inside a set of curly braces, all of the next level of things that you're doing ought to be tabbed in by one for formatting because it's cleaner. It kind of hints at you on the left side here with that line. If I delete those tabs, it shows that format is kind of broken. So it's a very small, subtle thing. It's a habit thing that I want you guys to start building, that everything inside that setup is tabbed once. Then you do something like an if, then it gets tabbed over again. And so everything inside that if should be roughly in a line for the sake of formatting, and then come back out So it's something to pay attention to on much bigger code. That will be a lot better. So in this, the way that I set up this code is in fact already doing this. So this first starting point. So I have them enter 1 for yes. So actually, the way I have this set up now, I have to reverse it. So enter 1 for yes for gluten-free. That means I have to switch these directions. So if the bread type is 1, it's really hard not to include error handling in this and set up else ifs and stuff. We will get there. We will get there. But I have to switch the logic around. I'll switch the logic around just because the variables need to match what our pseudocode does. So if the bread type is less than 1, then so if they answer 0 for no, bread type is wheat bread. If they answer greater than 0, meaning if they enter 1 for yes, they get lettuce or 44. So bread type equal 44. So bread type, it knows it's an already defined integer up here. So it'll highlight all the instances of bread type. So, but here I'm actually not going to do a serial.available. I'm actually going to do a serial.print. And I'm going to go ahead and do print line. Probably 95% of anything I'm ever putting into a print statement, I'm probably going to want to print line 95% of the time, as opposed to just a serial.print, because reasons. While I'm here, I'm going to add the colon so I don't forget. What main ingredient do you prefer? Enter these values for these things. And I'm going to do both quotes to drop that into so that I don't have to go chase the end down later. So what main ingredients do you prefer? Enter 1 for turkey, 2 for cheese, 3 for salad, 4 for salami, 5 for none. Then at the end of this, you want to hit enter and note that it will keep that same line. So it'll keep that same tabbing to keep things in order. We want to do a delay of, again, 300 milliseconds is reasonable. So what this is doing in practice is, again, comments so that we know where we are and what we're working on. The serial print line. This is about ingredients. So we're asking the user about ingredients. Then we're going to, after that delay, we're going to do another if, but we're going to do a read. So I'm not going to do another if serial available just because it's extra steps and it's a little bit cumbersome. So I'm going to keep this same approximate structure, but I really kind of have to redo everything again. So I guess I'll redo this from scratch just to keep this simple. And for the way that I've written the pseudocode, I'm not looping that input. So the void loop in the way that I'm writing this program. I'm going to say this is intentionally left blank for this specific program. So we're not actually using the loop. You can actually run an entire bit of code and do quite a bit within just the setup, because sometimes you only need stuff that'll run one time, and that's totally okay. So we're going to set the discipline here is, I'll put it in a comment so that the format makes sense. Variable equals input value. Essentially what this means is assign this variable to equal that input. So that's essentially what we're doing, is we're going to tell the program that I want main ingredient underscore main ingredient. I want that to equal serial read of whatever comes back from the user. So this sets, this assigns, so I'm going to do another tab for this comment. So this assigns main ingredient to now be equal to user input. So I wrote this the other day and didn't explain to you why it's bread type then equal then value. It's the same thing that we would do up here if we were setting an initial value. The discipline is variable name equals, so that's telling the computer take this variable, assign to it, and then function that does a thing or gets a number or just store the value, equal value 99, equal value 44. So this is an update to whatever was in the variable before, because there's always something stored to the variable. Even if you haven't put a value into it, there's some gibberish that's assigned automatically, even if it's like the equivalent to electronic noise, basically. But there's always something there. So after this, we're going to hit enter again, make sure that we're still tabbed over. Now we're going to do the comparison so that if, just like above, if, and then variable, for this one, let's see. This is another reason why I wasn't going to do an if conditional, because if we don't have to reassign, if we use the numbers, this is another part of the reason why I wanted to run into this as a roadblock right about at this exact point. I left this as a landmine for us to drive over because I wanted to make you think about options. I don't actually need an if conditional check to reparameterize. That's your $5. Maybe that's a $25 word, reparameterize. the variable from 1 to turkey. The reason I needed the if statements up here was to reparameterize from 1 or 0 to 44 or 99. So I did this line as part of the program yesterday, but you guys didn't know why I had to do it. So here I actually don't have to do I don't have to do the main ingredient. What I do need to do is then delay about at least probably 200 milliseconds is probably okay, because you don't want it to just be trying to run so fast. There are instances where a poorly written algorithm can almost trip up over itself because it's trying to do some of the outputs before it's even gotten the inputs. And if there isn't enough of a delay for somebody to write a response, and we'll see what this can look like. But if there isn't a response, this is where the conditional up here matters, if serial available. So if information is coming back, if an input has been given back, then read it. So I'm going to show you without that piece of it, and then I'm going to move a thing around and show you what it looks like working differently. So we're going to do some examples of troubleshooting with this kind of code, since you haven't ever had experience with this before. So the serial read, I'm going to do a delay of 300 again, 300 milliseconds. So main ingredient. So then we're going to ask about, we're going to ask the user about ingredients again and do a delay. And we're going to do a serial read and do it again. So this is what I meant by once we've put together that operational code block, we can copy and paste. So now we do another code block, but we say what second ingredient. We store it to second ingredient. And this assigns second ingredient. So we do the things. Then we do it again. So we paste again for third. Third. So then I do it again for fourth, and for fourth. So now we are at the simplest form of, we've got one more, and now we have to do output the order to the kitchen. So this outputs the order to the kitchen by saying dot print line, and we're going to have a few serial print lines to fill out. So we're going to have one for the order itself. We're going to have one for the bread type, one for the main, second, third, fourth, bread type again. And then we end. So this is going to be our bread type. This is going to be main ingredient. And this is why it's helpful to be detailed with the pseudocode, because it helps you to lay out the other stuff as it makes sense. There we go. Fourth ingredient, bread type. Okay, bread type. All right. So now we need our text. And by including that in quotes, it's going to print this as a string. So serial print line, serial print line, serial print line. All right. Now, because this is going to run once, there's a couple things that I want to do. I'm going to go ahead and hook up my Arduino. I'm going to first run a verify and see where it comes up with errors, because it will. I think these characters right here are, because they're a funny font, this won't get recognized as a string. So that threw it for a loop. Yeah, 68 out of 18. Okay. So we're going to say, please make this sandwich the same way that we're doing here, right? We're going to say, please make this sandwich. All right. So now if we verify, expected this before delay. Yep, because there's no colon. So there's all this little nitpicky nonsense. Let's find another one. If bread type is less than 1, yes, correct. That conditional is meaningless. That one's correct. That one's correct. Okay. So let's check again. Yep, now it compiles. So in case you thought that I wrote perfect code from scratch, again, see comment about I'm not Rachel Ray, which I know is surprising to you guys. I don't have a bunch of pre-baked muffins already in the oven, warm and ready to go, because I don't have minions. If I did, I would basically be Gru. So there's that. A couple people have analogized me to a real life Ron Swanson. Those were coworkers that worked with me for many, many years. So there was a long period of time where the pyramid of greatness was in fact hanging on my wall to point out to students where their failures were on the pyramid of greatness. So if you don't understand that reference, you are missing an important part of your humanity. You should go find it. All right, I'm going to go ahead and connect to the Arduino and load us some code so that we can actually see what the input output looks like. There we go. I need to make sure it's on. Okay. Okay, it's uploading. I then need serial monitor up. Come on. Come on. Serial monitor up. There we go. So now if I hit reset, we should get it running. Okay. So it ran, but what happened?
It didn't ask for user input.
Yeah. The program went by so fast. So fast. It didn't even get to print. I'm going to see if it prints a different number of the questions on reset. Yeah. So it's picking up by the time it gets to second ingredient. Because this is where that if conditional creates a little bit of a problem. So it sets -1 and 0 as those default values. So I told you there was already going to be some gibberish stored in those values as defaults, and that's what it is. So bread type is 0, and all the other ingredient types are -1. So even though we didn't set initial values, I could change that by working up here, but I know that's not where my problem is. So we do a serial print line. So we do a serial begin. What we then need to do is hold your dadgum horses. Okay. So let's do 400 millisecond delay. Okay. So first thing, slow down, Fireball. Slow down, Fireball. All right. We need to not have the program execute and just bypass the actual input from the people. So slow down, then print line. This is what I'm talking about an inadequately written program will almost trip over itself trying to get the input. We need to slow down until we've already asked for what's going on. So it needs to ask for a keyboard input effectively. So there's another serial function that we can take a look at that's specifically looking for keyboard input. But we want it to still print this. Okay, we want it to delay we want it to delay, in this case, probably by 600 milliseconds. Here, what I think I'm going to do is I'm going to take this and I'm going to copy it. I'm going to take that whole if serial available. I'm going to comment this out. Let me see. There we go. So control and then slash is comment out a whole block at a time. So there is a hotkey, it's control. And I think that one's the /. I never bothered remembering which one was forward and which one's backward. So the comment of that one allows me to paste just the relevant pieces of this. So set bread type to serial read. And then because there's no delay in this one, this gives the user some time to respond. If the user doesn't respond fast enough, then there's some other issues that can come up. But I'm going to walk through using just this part of the code without the if conditional for serial available, because the serial port is open and it's working, and we know that, and that's okay. Serial print line, what main ingredient do you prefer? Again, we're going to do 600 milliseconds and start there so that we're not just overrunning our timing. There's some other things that we can do for conditional to check for inputs. All right. So then, because we're ending here, we don't really need another delay. We could add one. But let's save it and reload it. Make sure I'm not on COM 67 yet. So it can also encounter errors when you go to compile. I know that one wasn't going to have errors because I was very careful. So we can also close the serial monitor. We can reopen the serial monitor. And we can say, all right, let's reset this. What main ingredient? One. Okay, so we got a couple in there, but not very many, right? So the user has to be on it. If I reset it again, okay, that time by being pro gamer on the response time, I was able to get in an answer for main ingredient, an answer for second ingredient, an answer for gluten-free. So I got 44. I got 49. I'm not actually sure what does mean 49 because that's not something that I wrote. But I think this is outputting because I didn't specify in each of these bread type decimal. So base 10. I need to specify these in bread type, and we need to slow down that input significantly. So this guy, delay for, we really need probably 800 milliseconds as soon as it starts serial, because it needs some time for our screen to even register at all. This is why things like timing on a user interface or laggy response time is a frustrating, annoying comment to get in feedback. So do you prefer gluten-free? Hold up. Then it's going to do serial read. So this, we can bump up to like 900 milliseconds while you're thinking about the question, because you've got to be able to read the question, then you've got to be able to respond to it. And with a question this long, what main ingredient you're almost a second just reading the question, right? So you might need 1200 milliseconds each time it goes to do that. So dropping it down to 1200 milliseconds and 1200 milliseconds and 1200 milliseconds and 1200 milliseconds. Then I'm going to reload it again. So recompile, replace, blah, blah, blah. Now we're back on. Serial monitor. Which do you prefer? One, enter. So even that first question, which do you prefer? that delay is not very long. I'm going to reset that again so you can see what's going on. Do you prefer 1? Yes. 1. Yes. 2, 3, 1. Okay. So it's still displaying in default value. Yeah, it's still displaying a default value. But there's a couple things that we can continue to tweak for some of these. The point is, it is taking some input now. It is responding in at least base 10 format, since we're using DEC. That gets us a start on a functioning program. So yes, there is effectively a wait response before moving to the next line. So the way that we go about finding that is, again, through let me see if I can pull it up in the Arduino language reference. There is a couple examples. I'm trying to think of what the easiest mechanism is, because there's a few ways to do it. There is a timeout, and let's see. There's a couple things you can do in terms of like variable sizes. There is a couple ways, like you can do an if comparator. You can do a while serial not available. There's a few others that I'm thinking of, and an if serial not available might be the most effective, but I'm trying to avoid having you guys have to put in extra layers of complication unnecessarily. But I know there's a number of the trouble with trying to use a while there's not serial is there's, especially with the fact that these have capacitive touch buttons and things, there is always serial data available. you can kind of make that work. Let's see. You can do yeah, trying to get the program outside of just manually forcing the delay. There's a couple things that you can do there, but I don't want to try and teach you guys using something like a while not serial loop as a timing interrupt isn't actually going to work, because there's always going to be some junk data stored to a variable that's available to bring back in over serial or something. So the easiest way is going to be to make a couple more tweaks. So I'll bring this back up. Yeah, that's really going to be the best way for now to deal with it, is manually increasing these times. So 1200 milliseconds, 1500, 1200. And if we keep that theme, 1500 before, 1200 after, 1500, 1200, 1500, 1200. This will slow things down, I think, enough that we'll get the effect that we're looking for. But again, this is why we have to just run things periodically. So I'm going to restart the serial monitor before loading the update to the program. That way we start with a clean sheet as an input. So we're going to send it. It's going to compile. I'm going to switch over to serial monitor as soon as it's done uploading. Okay, so it's going to give me a question. So it's already jumping to main ingredient, second ingredient. Yeah, so it's waiting. Interesting. So I was able to get one input through, but the timing wasn't actually delaying correctly. So this is still an example of an acceptable program that we would be looking for, because this is a viable example of output. If I get a couple of these in. But yeah, it's not even printing. Let me see if I can get it to print that first question. Do you prefer gluten-free? Yes. Okay. What main ingredient? 2. What third ingredient? 5. 5. 5. Okay. Yeah, why it's storing those to 49, 50. Interesting. If I set the default value for these to 5 for none, that's going to change our output, but it should. So it correctly changes these two. But why is it making up nonsense from the serial read? That's the next question. So another option that we've got, we can go to the language reference. Let me pull that up. Because a while not serial is going to really make life harder than it needs to be. So under serial, there's a couple commands. I'm going to go back to this. Here we go. So available functions within serial. This will be helpful. So there's available, there's find, there's also serial.parseInt. And this is where like you can read individual strings, but what we might need to do is I don't want to specify buffer and length yet. That's a little more advanced than I wanted to go. What the read is doing is just simply taking whatever's coming in as an integer and storing it. So serial.read, variable name equals serial.read, and then print what it received. So if there's no data, it'll be -1. So the serial read process is what's getting us some integer results. So we're using serial print line, and then your options are decimal, hexadecimal, octal, binary. This default is about the same. Binary is not going to help us really, but what they're meaning right here is information on the asynchronicity. See the notes and warnings, and what we're having in terms of printing out the values to the serial monitor is an asynchronicity, meaning that we are getting things to print out. However, sometimes when you're storing values, you can come up with some unexpected results. This is one that is sometimes used as kind of an interrupt. So get the number of bytes available from reading the serial port, so the data that's already arrived. This, however, if serial available is greater than 0, that's the condition that we were using, then read, and then I received. So we can go back in and add the if serial available for a conditional for each one. And then effectively what we're doing is doing that in a loop, only we're doing it manually line by line. The flush serial in this case doesn't actually help us. So there's a couple others in there that that don't really help. And then serial.end is closing the open serial port. So that one's fairly self-explanatory. So you can kind of use if serial conditional. This basically returns a true or false. Once the serial port is connected, the while not serial can help, but this returns a data type called a Boolean, which is true or false. So we're not usually using that. You can for some more advanced things, but it adds a delay of 10 milliseconds, and it attempts to solve the open but not quite situation. Don't use it in tight timing loops. That's what we were experiencing with as it connects. You might not see that very first question actually get displayed, because even though we manually added the delay up here, serial begin delay, even though we added that, there's still a lot of stuff going on. So do you prefer gluten-free? That will show up. You do have long enough to respond. It will read in, but you might actually want 2,500 milliseconds in between each question printing and the actual serial reading, and we'll see if it's better with 2,500 milliseconds. This is where we have to make kind of just some manual estimations. So if I reload this, update, compile, get across to the thing, serial monitor, as soon as that sucker's done uploading, we will get a question. Done uploading, serial monitor. Okay, yeah, so we already have to hit 1. We have time to hit 0. We have time to hit 5. We have time to hit 5 and enter. So we missed the first one, but we got the others here. So the way that those integers are storing is strange. So I'm going to do a quick test just to see. I'm going to do it in the second one, since the second one is easier to actually spot on here. I'm going to do it on the second one. So I'm going to do the same delay of, still a delay of 1,200 milliseconds. This is going to be comparing the variable, same kind of idea. We're going to compare the variable, but I'm going to do it on the second ingredient here when it goes to read it in. Before the delay, I'm going to add in this logic. Second ingredient. If then it's going to be, I'm going to add a different, kind of conditional here. And I'm going to do if second ingredient comparable to, meaning two equal signs, if second ingredient is to store 2, if it's 1, store 1. So this is just going to be an override. Else if, else. So I'm going to clear these just to make the copying pasting a little bit smoother here. So if second ingredient was 1, else if 2, else if 3. Else if 4, 4, else second ingredient all else, this guy actually just needs else second ingredient is assigned to 5. Okay. All right. So else second ingredient assigned to 5. Okay. This guy gets tabbed over as well. If this else if else delay. Okay, this a check for errors. Good. Logic is sound. My logic is always sound. All right, we're going to upload that. And we're going to start serial monitor. So we should have serial monitor. I'll restart that again. There we go. All right. So we're going to reset this now that we got communication back. So I'm going to let it run by itself so that you can see all the steps first. So it's going to run through, do its delays, no inputs from me, and then you're going to see what the output looks like. So now we have 5 as our output. So now I'm going to reset one more time and change 2. So we're going to change input 1. So yes, I prefer gluten-free. We're going to do 2. Second ingredient, we're going to do 3. Third ingredient, we're going to do 4. Fourth ingredient, we're going to do 5. So even in that circumstance, I bet let's go back to conditionals. I think that else if structure has to have parens rather than curly braces, if I remember correctly. Yeah, each if needs to be self-contained, else. If else. That's the pairing I want. Else if, no, I got that right. Else, da 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 da, else if condition 2, yes, do the thing, else if condition 3. Okay, so something about the way that data is reading in on this specific one. We are getting so it's not seeing integer input from this COM port is what this says. So it's correctly associating 5. But why didn't it take? Let's see, set second ingredient to 1, set second ingredient equal to 2, set second ingredient equal to 3. You can also do this as serial read. Because you can do conditional for serial read inside of these values. Yeah, else if, else if, else if. So correctly structured logic, but the way that the data is reading in from the keyboard is not storing exactly in memory like we want to. And that's why we are getting the data that we want, or we are getting the data that we're getting there, because yeah, so second ingredient. So those are all spelled the same, so that part's correct. There's no errors there. So if I change the conditional to be second ingredient to be an else if, else if, else if, else if. Okay. Second ingredient is 5. I'm not going to do a final else condition because I'm checking for one specific kind of error. Uploading, serial monitor. Okay. So interesting. Yeah, it's the command that's coming in. Is I'll have to play around a little bit with it and see what the serial monitor thinks it's coming in. This is a case where I would redirect you guys in the live class to take an input from like the left or the right button or something, we would do one of the button press inputs instead, because that would help to kind of clarify some of the challenges here. Yeah, so this is doing what it's being asked for, just not in the way that's expected. So it's reading a response of 1 for the first question. It missed the response for the second question. It got a response for the third, fourth, fifth. I still don't know why it looks like we're getting like a hex address format out when they should be stored as decimals. But again, I would need to crack into the live serial stream to see what's actually coming in. So yeah, that is very interesting. So I can force it to output a simple integer, but I can't somehow store that serial input to a simple integer, even though it's an integer type. So this gets into the part of programming that doesn't make a whole lot of sense as to why. But the program is actually doing what we've asked it to do, aside from the values that you're seeing being output here in the center. So the left column is more or less correct, but the right column isn't, which is interesting. Yeah. I don't know why it's adding another digit there, but again, I would need to crack into the serial data stream to see what gibberish is coming across. There's all sorts of weird things that can cause that, including having kind of a cheap or low quality serial cable, running it through lots of different USB to C adapters back and forth, all those sorts of things. All of those add complication to serial data read and write. So anyway, that at least gives you guys a pretty high level overview, and gives you guys a couple examples of some things that we can do and where we put input in from that COM port. And it does look like it's still sitting on 5. So it wasn't like on COM 6, because otherwise we wouldn't have really any of that going on. So other questions? Yeah, the
So
serial available is probably that is as close to an option as you're going to get. The trick is there's always going to be some gibberish coming back on the serial port because reasons that are down to the actual physical hardware of the board rather than the code that we're writing. So this is why we're going to move on to other examples of looking for input. Other questions?
for some reason, every time I try to just verify the code, even though I tried to follow your instructions as close as I could, it keeps having error messages after the delays for some reason. And after every ingredient, it says like there's an error in the delays. I don't understand why.
So usually if it's saying there's an error in the delay, or there's a semicolon expected before the delay or something, is fairly common. You've got to end each serial print line with, after that final parentheses, you have to have another semicolon there in order to tell it to stop and go to the next line. Otherwise, you're going to continue to have errors. Or if it's not, if your text is not in quotes correctly, So remember the example where it pasted in quotes with a different font.
Yeah.
So they pasted in as characters rather than as quotes. You want to physically manually type the quotes at either end to make sure that it closes the text string. Otherwise, you're going to have all sorts of heartache.
Yeah. I did do that.
Okay.
And there is semicolons where they're supposed to be. I don't know. It's
Because normally, as long as the delay is set up as a function, it's spelled correctly, it has opening, closing parentheses, and it closes off with next line from a semicolon there. Normally, those are not going to be things it'll object to. So I might have to see the specific error message to be able to see what that's doing.
okay.
Okay. Other questions on this? I'm sure a couple of you guys are going to go to recreate this and run into all sorts of red love letters from the program. That happens. Working through those one by one is part of the rite of passage, sort of like becoming a knight, where they would do the practice of buffeting. If we were to bring back buffeting into our society, we wouldn't have people clamoring on TikTok about how horrible and awful it is to not work for Twitter again from like 2017, where they got like free food and lounge chairs and like company colored yoga mats and all the other nonsense. Type conversion before. So the let me paste that somewhere where I can see it a little bit more clearly. So somewhere before that line, wherever it's tripping that error, there's another error. Maybe you've got a couple sets of parentheses where you've got a pair of closes and not enough opens, or you've somewhere got a mismatch in the code. So there is an error. Code is one of those frustrating things where it doesn't send error messages when it's actually all correct, but it will always send error messages when it's not 100% perfection. Always, always, always. So somewhere above that line, whatever that line number is, there is there's an error, whether it's a issue with the loop or setup. Somewhere in the code there, you've got a mismatch of parentheses, or you're missing an end quote for something. And it can take a while to find those. Okay. Other questions on this? On a scale of 1 to 10, with 1 being dry dirt and 10 being holy water, how clear are we feeling about the jump from pseudocode to code today? Yeah, I expected some 3s and some 5s mostly, so looks like that's right about where we're at. Okay, good. Well, the good news is that's actually right in the range where we want to be, because there's still a lot more to learn, but this will at least help give you guys a starting point for where to be looking for some of the errors, because the program, especially when you go to actually run these and try and record the output, you'll very likely have to reset the board a couple different times to be able to get the timing right. So you'll want to play around with some of that until you actually get that working the way that you're trying to. So that's the main core of the content for today. I'm going to give you guys some time to go work on kind of finishing up your algorithms and chasing down some of those individual challenges, the making sure you've got all the right number of open and close quotes and open and close parentheses, open and close curly braces, and all the rest. You're going to be turning in, this is the code that you're developing for the part 1 of the assignment. Or is it actually part 2? Is it, let's see. Part 2 is flow charting. Part 3 is pseudocode. Yeah, part 1 is the actual code itself that you're looking to develop. So I would say go ahead and do that one. This gives you a pretty solid starting point for what you're looking for to turn in for that assignment. So, all right.
I had a question regarding part 1 versus part 4.
Okay.
'Cause it looks like part 4 is the writing code, like using parts 1 through 3. I was just wondering about that.
Yeah, let me look at that may have been one of the, implementing the algorithm. Okay. So yeah, this is, I guess this is technically working on part 4 to generate the code. That's one of the updates that happened, it looks like, in the recent class revision. So for this first part, for part 1, what you're actually doing is see, the interesting part about this is okay, so this is looking for what the code would look like for just a single ingredient chosen in the middle. So this is just looking for you to actually write what the code would look like for a single ingredient. So it's like what we've done here for the multiple ingredients, but condensed down to just a single ingredient. Yeah. So for this, you're essentially writing the way that they've set up part 1. You're essentially writing pseudocode for just the single ingredient. Then for part 2, you're looking at this multiple ingredient, the one that we've been working on. Part 3, you're doing the pseudocode for the multiple variations, and then part 4 is implementing the actual algorithm and writing the full detailed code. So that's what we were working on today. Yeah, so you're actually right in line with learning the stuff that you need to, even though you might sort of feel, I'm going to say, you probably, at least a few of you, are feeling a little bit like Lucy, and the world is a little less hospitable than you expected. So few of you will probably get that reference. That's fine. Others of you will get it on the way home. That's also fine. So yeah, you'll simplify down the code to the first ingredient and then go from there.
Okay, thank you.
All right. Any other questions? If not, then I'll go ahead and close this out and try and get that, see if I can get that recording posted for later today.
I have one more question about
Yeah.
an error at the beginning of everything. It
Okay.
says error serial USB does not name a type of sorry, does not name a type define serial. Uh did I
So
did I miss something in the beginning? Was I supposed to, because I have
um,
serial begin like yours has.
yeah, is it capital S serial dot begin and then parentheses with a timing, like 9600,
Yeah.
and then your semicolon?
Yes.
If that's the case, that should be correct. Um, because serial is uppercase, begin is lowercase. Um, uh, let's see what else. Let's see. Serial that begin. Um, yeah, I'd have to see what's physically on the screen to be able to diagnose what's going on for that one, because it's, as long as you've got capital S serial dot begin, then you've got open parens, 9600, close parens, semicolon. That should open the serial port. Usually where it's looking for defining serial is if that whole like serial dot begin is not recognizing, because of some other contextual thing, is not being recognized as a function, like your void setup, the opening, um, one of the parentheses accidentally got deleted or something. Like there's a lot of little stuff.
Gotcha.
So there's any number of little things that, this is why I say coding is like working for the most hostile English major on planet Earth.
Hmm.
It's also something that there will be times when you can plug your existing code into something like ChatGPT and say, can you fix the error in this code for the Arduino language or something, and see where it highlights, oh yeah, you forgot to whatever. I don't know how well that works, but you can try in the absence of something like office hours. That is a reasonable thing to attempt and see if that helps. I don't know how extensive its code troubleshooting actually is, but that may be something that can be a help.
For sure. Does it matter what COM, like if it's COM 1 or COM 5 of the Adafruit circuit playground thing, or does it not?
It doesn't really matter what COM port it's on, so long as that's the COM port that you're communicating to and monitoring.
Okay.
It's just something that you have to know, hey, this is where it is, I'm going to communicate with it there. So depending on how many devices you have hooked up, if you then move your laptop back to your room and you plug in 6 more peripherals to USB and stuff, now it's a different COM port number, because a bunch of those other COM ports are now mice and keyboards and headsets and whatever else. So those numbers change, and so long as you're consistent and paying attention to which one you're communicating to, that shouldn't be an issue.
Okay.
All right. Any other questions?
How would you like us to continue on this code moving forward? I had trouble with the errors as well, like with it not giving the right
Yeah.
output.
The errors from today are those are errors in terms of how data is coming in. I have my suspicions that this actually has to do with the way the bus works on the Circuit Playground Express. Because it is taking input, it is making changes to the memory assignments based on the input, so I can put in different numbers and get different output values. However, without actually looking at what the live data stream is on from the Playground Express, I don't know if it's also picking up values from the interference from the capacitive touch buttons, or there's some other level of thing that's happening. So I'm not looking for you guys to perfectly fix this and implement this. If it was a simple example, then it would be this would be a little bit easier to explain why the data type is doing something different than what it should be, because it should be storing the exact same integer that comes in from the serial read, and on an Arduino Uno, that's exactly what it would be doing. So if you were to take that same code, you were to drop it into Tinkercad, and you were to run it in Tinkercad on just a blank Arduino, it would still, you could still bring up the serial monitor, you could still do the things. It would likely not have the exact same errors as the Circuit Playground Express, because this is the thing that I lump under the category I call reasons, which I stole from a YouTuber and have used ever since, because I know why it's not doing what it should be doing for this circumstance, and this is why I argued that the Circuit Playground Express was not probably the right choice. But that was not a factor, because everything should work just exactly the same, except in practice everything doesn't work exactly the same because reasons. So I'm not expecting you guys to have this code working perfectly. I'm expecting you guys to get it to the point where it's clearly attempting to output the order for the sandwich stack. And if it's doing that thing based on the input and you can show a couple different outputs, then you've done the thing for this code. Does that help answer the question?
Yes, thank you. You think it's just like a communication problem with the board and the computer?
The way that the developers for the Circuit Playground Express really only sort of have formal support for running C++ compiled on the boards. The development for the Arduino Unos was exclusively set up for compiling in C++ through the Arduino platform. What that means is weird stuff like this can crop up on the Circuit Playground Express that can add levels of confusion that make it unnecessarily hard to learn, because the board is actually doing it what I'm asking it to do, except the result that it's spitting back is not exactly what I've told it to store, because of how that interface support works, and it's a third-party patch to get the serial communication to do the thing. So it works, but also it doesn't work at the same time. And that's just,
Okay.
so again, that insertion of third-party components in order to make it all quote unquote work is why I said this is going to cause unnecessary confusion. Let's just use the Unos. And that was not what we did. So that was not what we did. So I didn't know all of the possible outcroppings, but I knew stuff like this would come up in the classes. There's not much I can do about it. So I'm not expecting perfection. I am expecting you guys to be able to get to the point where it is taking inputs, it is giving back an output. If we've done that, then we've accomplished the thing.
Okay.
The likelihood is,
appreciate it.
like, you'll never be using a Circuit Playground Express in a real project ever anyway. You'll be using some other system, and it'll have its own compiler, and that compiler will have its own issues. And all of these things are challenging and difficult. Anybody that tells you otherwise is probably a salesman. It's really what it is, right? All right. As far as turning in the assignment, the first one you're going to turn in, the first one you can turn in either code or pseudocode for part 1 for just the single ingredient. Then the other parts 2, 3, and 4, you're going to keep working on the diagrams and things that we've done for the multi-ingredient version. All right. If there's no other questions, then we will pick this up and reconvene next week.
Thank you.
Take care.